Okay, so now we have a very interesting presentation, again coming from the manufacturer, but this time not from the back contact, but from a perovskite background. So we have Fan Bin, who is chairman of board for the GCL Perovskite wing. He's going to talk about perovskite-based tandem PV modules. Fan, I think you also have very exciting information to share.
Yes, thank you. It's my honor to have the chance to introduce ourselves. So now I'm sharing my screen. A moment. I'll have to restart the Zoom because of my computer. So one moment. I need to restart my Zoom.
Okay, please go ahead. Okay, Sebastian, so are you online? Can you hear me?
You're asking myself, Sebastian?
Yeah.
Yes.
So,
yes.
so meanwhile, I just have one more question. Like, so is the capacity going to vary between cell technologies? For TOPCon, for heterojunction. So is it going to vary?
No, for TOPCon, heterojunction, and also IBC, I do not expect that this will vary. For tandem devices, we have to look on the evaporation side. So when it comes to PVDs, magnetron sputtering, I also do not expect any variations. But because this technology, the sputtering technology, is already developed in a substrate in a width of 3.3 meters. But for evaporation, as I showed you before, we can scale it just to today, just to sizes of 700 megawatt equipment.
Okay, great. So thanks a lot.
Thanks.
And probably you can start your presentation. Thanks.
Okay, yeah, I share my screen. Can you see my screen now?
Yes.
Okay, great.
But you have to go into the presentation mode. Yeah.
Can you see my PPT? Okay, great. So I'm going to talk about our project on tandem perovskite module. We start with perovskite model there, and now we are able to make tandem module as large as 2,000 square centimeters. And this is our point on the industry. Since now the cost of silicon is getting smaller and smaller, the proportion of the silicon is getting much smaller than before. So now the power conversion efficiency is getting also much more important than before. Not just the cost of the module, but now the efficiency matters much more. And we can also see that in many countries, the module cost, the proportion of module cost in the whole system is also getting much smaller than before. In European countries and in Japan, it's even less than 20%. So we can be sure that the efficiency is the most important thing. And talking about perovskites, perovskites is a kind of a artificial crystal, and it's based on the artificial design of the formulation. So the evolution of perovskite is very fast. We can see a very fast growth of the power conversion efficiency, and we can also see a very fast improve of the stability of perovskite modules. And talking about the efficiency, we can see that the efficiency of silicon is now reaching a pretty stable line. Yesterday, we just read the news about Longji have 27.0% efficiency, and in the past 6 years, the increase of the power conversion efficiency for silicon laboratory cell is only 0.3%. So it's like hitting the roof. But for perovskite, we can see that it starts from less than 3% at the year of 2009, and now for monojunction of perovskite, it has already reached 26.1, and more importantly, the tandem cell has already reached more than 33% efficiency. And so we are quite sure that the most important benefit from perovskite is that it can bring the power conversion efficiency further up, and which is very important to the whole industry. And we can also see that the cost of the material for perovskite is much lower than the cost of silicon, because it requires a much lower purity, like 90% is already good enough. And the usage of material is much less than silicon in each modules. And for the production cost, for the production capacity investment is also much lower than that of silicon. Now it's still quite expensive because the scale is pretty small, but we believe that when perovskite have tens of gigawatts of capacity, the cost of the capacity will be almost like half of that of silicon. And higher efficiency and a lower cost means lower levelized cost of electricity and higher return for clients and more adoptions. And we believe that perovskite can be used in any kind of field. It can be centralized PV power plants, it can be distributed PV, and it can also be used in building integrated PV, and it can also be applied on vehicles. And the production of perovskite, the manufacture of perovskite can be completed in one single factory, and takes about 45 minutes from end-to-end production. It's a pretty fast procedure. Compared with silicon, you can see that silicon manufacturing goes through 4 main factories and for one panel, it takes at least 3 days from end to end. So perovskite is much faster. And the problem about lead, we know that a lot of people always question the usage of lead, but there's a fact that in perovskite modules, it contains much less lead than that of silicon, because the silicon used the lead for the welding, and each module contains about 16 to 18 grams of lead. But for each module of perovskite, it contains only 2 grams of lead. It's much less than that of silicon. So we are not bringing in more harm to the world, but we are reducing the application. We are reducing the usage of lead, and the production process of perovskite is much greener and emits less carbon oxide. It's simply because the temperature applied is much lower than that of silicon. In a lot of typical procedure for silicon production, the temperature goes as high as 1000 or even 1500 degrees. But for the production of perovskite, the whole procedure is lower than 200 degrees. And I want to talk a little bit about our company. Our company is founded in 2010, and at the beginning we are working on organic PV. And in the year 2013, we switched from OPV to perovskite. And so we are one of the first companies in the world that dedicate to perovskite commercialization. And in the year 2014, we start to construct the 65 by 45 centimeter module, an R&D line. And it was the largest perovskite module in the industry at that time. In the year 2016, we are acquired by GCL Group. So we rename us to GCL Nano, and then later on we rename us to GCL Optoelectronics. And now we are officially called GCL Perovskite. And in the year 2019, we obtained the first TÜV Rheinland certification for perovskite module. That's the first certification of perovskite module by a TÜV Rheinland. We also raised a lot of funds from some top investors like the Partei Capital and the CATL and so on. And later on, we start to construct our module production line of 2 meter by 1 meter size. And that's already quite big as the old standard for silicon. And it's the first industry-grade perovskite module in the world. And now we are setting up and now we have recently achieved 18% for 1x2 meter module, and we have recently achieved 26.3% power conversion efficiency for a 2000 square centimeter module. And now we are setting up to construct a first gigawatt in China. And that's our recent achievement. This line, this dark blue line represents the 45 by 65 module. And recently we have achieved 20.6% efficiency for that. And the lighter line here represents the power conversion efficiency for our 1x2 meter module. And in the year 2021, we reached 10%. That's the first year we are running the line. And the second year we ran the line, we achieved 14%. And this year, by the end of this year, we now have achieved 18% certified. And we are now constructing the first megawatt scale demonstration power plant. Is located in Qinghai province, in Western China. And we should be able to finish the construction by the end of this year, maybe in the days of Christmas time. And our technology is shown as here. This is our 1x2 meter module, and is 2 square meter large, and is taller than me. And the production procedure is like we deposit whole transport layer, and then perovskite and an electron transport layer, and then back contact, and then a PLE film for the encapsulation. And here, only the perovskite layer is coated by salt coating. All the other layers are deposited by PVD. So we can use a lot of our PVD technology from display panel industry, and also from semiconductor industry, and also from our patterners in silicon industry. And we can see that our modularization is formed by laser P1, P2, P3, and P4. That's typical for thin film PV modules. And what I want to emphasize here, what's the most important achievement recently, is the tandem module. We always believe that we should first finish our research on mono-junction module before we can really go to tandem. And now, since we have already reached 18% efficiency, we believe that we are good enough in the single junction module. So we are now able to construct a tandem module of this size. We are talking about good enough, doesn't mean we will stop here. The efficiency for a single junction perovskite module will still grow. It will grow to 20, 21, 24, and it will not stop before, I think we will not stop before 26% efficiency. But now we are able to construct a tandem module, which is already better than any kind of single junction silicon module. And our strategy to construct the module is that we deposit perovskite layer on this top glass. That's the complete structure for the perovskite module. And after we construct this perovskite module, we construct the silicon module here, and then we put them together, make a tandem. So this is a module scale tandem. That's the module to module tandem. And this two module is matched by the voltage. So it's a parallel connection. The voltage of perovskite and the voltage of silicon is the same. So it's still a double connection. It's a two-terminal module. It's not a four-terminal because it's matched with voltage. And this is the typical strategy which come up with those producers of silicon. They manufacture the perovskite cell on top of silicon cell. So we can call this a cell scale tandem, cell to cell tandem. And after they have this tandem cell, they connect these cells to form the module. And the problem with this design is that although they can make pretty high power conversion efficiency with a very small area, like 1 square 1 square centimeter, they can reach 33.9%. But when they come to larger size of the cell, like 200 square centimeter or a little bit more, the efficiency quickly dropped to something like between 25 to 28. And well, I would say it's not that significant improve comparing with single junction silicon cell. But with the module scale, now we are able to achieve 26.3. Now it's already better than any kind of silicon module. And the problem is that because the surface of the silicon cell is not even, we know that is texture here. So if we need to fit the texture with perovskite, it's quite difficult. And as we know, the texture is like the scale of a micron, but perovskite, the thickness of perovskite is only hundreds of nanometers. So it's very difficult for perovskite to fit in all these textures. And also, each crystalline silicon tech root requires different perovskite formula because they are physically connected. And the design of perovskite in series structure is complex and much, and it will sacrifice stability, as we know here. But if we make the tandem in a modular way, then we don't need to think about solving the problem like these textures. We just solve these two problems separately. We produce perovskite on the basis of glass, and which is the best way for producing perovskite module. And we don't need to change so much for the silicon also. We just need to increase this output voltage, which is not that difficult. It's quite simple. So after we have this large area, high efficiency perovskite module, we can see that we have already finished maybe 95% of the work for the tandem module. So this is what we achieved recently. In the year 2021, we have 10% on this 1x2 meter module. In the year 2022, we have 14%. And the year 2023, that's this year, now we have a 18% for this mono junction module, and we have 26.3% efficiency for this 40x60 tandem module. That's the first real tandem module in the world, because all the other reports we have seen is only for the tandem cells. And this module efficiency is already much higher than any kind of silicon modules. And next year, we are going to have also 26 on this 1x2 meter tandem module. And we will also finish our construction on our gigawatt line phase 1. And by the year 2025, we should be able to finish our phase 2, and we should be able to reach a tandem efficiency over 27% with this 2.4 by 1.2 meter module. And now we have all these good investors like Cartier Capitals and Tencent and IDG Capitals and Sequoia and Temasek. And now we are constructing our first phase of gigawatt line. So thank you very much. Thank you very much.
Okay, thank you very much, Pan, for this nice overview. So, you said that tandem module efficiency of 26%, right? So, what is the bottom module?
That's a TOPCon module.
Okay. And do you see any benefit with changing the bottom module, or do you see any issues, or is it kind of really flexible? You are free to choose whatever the bottom module configuration you want.
Yes, because we just need to match the voltage. So any kind of a bottom module can be used. TOPCon or even PERC or IBC or HJT, all this can be used. And but still, the HJT will be better because HJT has a higher voltage and consequently has a lower current. And so the loss of current will be less. It means because by sharing with perovskite, the most affected thing is the current. So that's why HJT is still better.
Okay. And how is the reliability of your single junction perovskite, and have you also done any reliability tests for the tandem structure?
Yeah, for the single junction, we have already done the IEC 61215 test internally, and our module can pass all the tests. And now we have already sent modules to like TOV Highland for the certification, and hopefully we can get the certification in the middle of next year. And for the tandem, I think for now it's depended on the stability of single junction of perovskite. Mainly depends on that.
So thanks a lot. And I think there are also several other questions in the chat window. Please stay online and answer these questions. And again, we will see each other again in the panel discussion, right?
Okay.